wanted to discuss what was the most critical thing for me throughout my career and all of the software discussions I've engaged in. And so this talk, fair warning, is not very software technical, but the topics that we're going to discuss are critical to building really effective software. And there's definitely a technical aspect of it. And so let's dive into it. So about me, I work at GitLab. I am a senior front-end engineer, but that's just what they pay me to do. I end up touching lots of other parts of GitLab and trying not to break things. I have a master's in software engineering, where a lot of this, what I'm about to present, I first was introduced to these topics. My interests, I'm the kind of person that's interested in a lot of things and risks not doing anything because I'm interested in a lot of things. But anything creative, I just have a lot of fun with. I link to some of the side projects that I'm proud of these days. One being conventional comments. I do a whole lot of code review. And doing this code review, I've learned that communication is critical. And conventional comments is a small little article preventing a convention for writing good code review comments. I also have an incredibly humble YouTube channel. I don't recommend you check it out because I just do it just for fun, called the Open Source Function. You can check it out if you want to, but don't get your hopes up. And you can find me across the web as, I call this Soul Design, but it also looks like Soul Zen or Soul DZIN. And that's me. But let's dive into it. So imagine you have a requirement. When the user hits play button, song plays. Right, today we all use our phones. Some decade-ish ago, we all had portable music players. And there were lots of different portable music players. And there was the iPod, and there was the Microsoft Zune, and there was everything in between. But functionally, these all had basically the same requirement. I am wanting to pause here to open up the Zoom chat. I meant to say this, but I really, really like being interrupted. And if there's a question or something comment that someone wants to interrupt and talk about, please leave a comment on the Zoom chat, and I'll ask you to vocalize or share that, because I think when we have a synchronous discussion is the most valuable. But going back to this, you can have the same requirement, lots of different implementations. And so what separates a poor implementation from a lovable one? And hopefully as software engineers and things that give us the most satisfaction in our work is building a lovable product that's actually going to solve user problems. Building a product that just meets contractual obligations may not actually end up being a long-term approach, because at the end of the day, whatever we build has to bring value. And those things that bring value in a great way end up being lovable. And so that kind of soft quality we're going to try to unpack. Here's something really special is sometimes the user doesn't even know why they love using this thing and don't love using another thing. And that's actually a really, really powerful effect. If you can build a product that's so smooth that when the user uses it, they intrinsically start trusting you're trusting the product, and they don't even know why they have so much positive affection towards it. That's a really powerful effect that you've had. And so that's something that we want to try to strive for. And as we've seen and used software ourselves, that we use it and we're like, this is fantastic. That is what we're trying to shoot for. And you don't get there by accident. And you don't get there by just being really, really good. Okay. A lot of what I'm about to talk about comes from this textbook, which, like all textbooks, is a textbook and is a little dense. But it's what it presents is pretty profound, but it's called Software Architecture in Practice. If you look it up on Amazon, it has mixed reviews. Some people really like it. Some people don't like reading textbooks. I'm hoping that it's got poor reviews because those people just don't like reading textbooks, not because the content is boring. If the content is boring, then the rest of this presentation will be boring. And I'm hoping that's not the case. But I'm going to try to make the presentation exciting. But here's a quote from here. And this is kind of setting the tone of what we're going to talk about. So this book is titled Software Architecture, but a large portion of it is dedicated to quality attributes, and mainly because you can't architect something unless you know what are the quality attributes of the thing going to be. And so I'm going to read this quote. But many factors determine the qualities that must be provided for in a system's architecture. The qualities go beyond functionality. And systems are frequently redesigned not because they're functionally deficient. The user can still kind of do their task, but because they're difficult to maintain, port, or scale, or they're too slow, or they've been compromised by hackers. All of those things that separate a poor implementation from a lovable one, those are the main reasons why things have to be redesigned or re-implemented. And we can probably think of many cases in our heads of products that, yeah, you kind of hit the requirement, but you really missed, some of the low level constraints that are required. And so the whole thing is completely invaluable. But to unpack quality attributes and to set the stage for the need here, I want to visit the software development activities, whether you're doing waterfall or agile or any kind of software development lifecycle. These are activities you're going to engage in. One is the requirements elaboration, design, interpreting the requirements and setting a plan for how we're actually going to build the thing, and then implementing where we're actually doing the thing. Because we're human, things can go wrong at any one of these, and things can go wrong when we elaborate the requirements, when we could misunderstand what the user actually needs. And because whether you're doing agile or waterfall, because each of the design and implementation activities, they pull from the artifacts produced from the requirements, whether it's JIRA issues or an actual, gnarly, huge requirements document. That requirements defect is going to trickle down to the other activities. Similarly, if we mess up something with the design, that's going to trickle down. And if we mess up something implementation. But the main point here is that requirement issues are the most expensive, for sure. If I mess up something in implementation, I'm just going to go back and fix it. That's no problem. If I mess up something with the design, I'm going to have to redesign a little bit. That's a little bit more involved, but that's not as big of a deal as, well, you didn't even build the thing that actually helped the user. And so this is a small block. Sometimes this is a small red block. Sometimes requirement issues can be quite significant. And we want to solve those issues as soon as possible and reduce the risk here. So to understand that and to reduce the risk of missing the requirements, we're going to dive into what actually makes a requirement. Requirements bring some sort of business value. And they have some sort of effect on the architecture. Not all requirements are the same of architectural effect. The user likes to go, all buttons have to be rounded buttons, does not really affect your architecture or something. But if a user, really wants to be able to switch between light mode and dark mode, that's a much more significant architectural requirement. So not all requirements are the same. As you analyze something, you could be thinking about, okay, here's a new issue that came in. Is this high business value? Does it have a low effect on the architecture? Is this low business value, but it has a high effect on the architecture? And the decisions that you're going to make after analyzing that make a difference. So making sure that we don't treat all requirements the same. So just think for a minute and think, okay, we built the product. Maybe we're, haven't completely released it, but we're, a milestone or two before releasing it. And what if we missed a high value, high architecture requirement? And maybe even the customer missed this. We didn't really interface with the user and we missed something that they really needed. That could be really detrimental to a product. And if you try to shimmy that in and to something that's already built, that's when hopefully whatever you've built isn't fragile. And that's when things can really break apart. And where you hear about, oh man, we're in crunch time because of some sort of scope creep. But maybe the problem isn't really scope creep. And maybe we're all dedicated to not just fulfilling some sort of contractual obligation, but delivering actual value to the user and helping the customer figure out what that is a big deal. On the other hand, if we have a high value, low architecture requirement that came up later, that's not as big of a deal. So this helps us frame the problem a bit of when we talk about reducing the risk of this problem, we really want to see, I want to know what are the high architecture, high value requirements as early as possible. Okay. I'm pausing for effect. All right, the effect has passed. So requirements fall in two categories. Your functional requirements, what the system is actually doing, the specific behavior of the system, and then non-functional requirements. And these are the quality attributes, how the system does the thing, a trait of the system's behavior. The functional requirements, a non-functional requirement, for example, like reliability, would almost have to describe every other kind of functional requirement. And so what do you think is likely an architecturally significant requirement, functional or non-functional? If you guessed functional, you would be wrong. The answer is non-functional requirements are most likely the architecturally significant ones. And they're most often the overlooked ones in the entire software development lifecycle, because they're hard and because they feel soft. They feel like you can't formalize them. It just has to be really good. So don't fall into this pattern where the project manager asks you as the software lead, hey, did you remember to ask about the quality attributes? And you reply, oh yes, it has to be really good. If you set yourself up without formalizing what the quality attributes are and you just shoot for everything has to be really good, you're going to set yourself up for failure. One, because there's a lot of confirmation bias with what is really good. You may not even be aware of the level that good needs to be at, or how certain quality attributes trade off with each other. And we will dive into that. And so these decisions have to be made at a project by project basis for sure. So we could do much better than just saying the system shall be really good. And definitely don't say the system shall be secure or the system shall be usable. We got to do better than that. Okay, I'm moving on. So you got a new project and you remember some guy saying something about quality attributes. So you're like, oh yeah, we got to do something with quality attributes. So you Google quality attributes and you hit the Wikipedia page for quality attributes and you see this glorious list of all the quality attributes you could ever want and then some. And you're tempted of like, well, I guess I gotta just click through all of these and see, did we think about orthogonality? And I would suggest not wasting your time doing that. There's a better way to approach this problem that has been addressed by the industry. A lot of these words are very related to each other. For instance, a lot of the words that you can see I've already clicked on are related to each other, such as maintainability and modifiability. So I'm going to give you just a couple to keep in your head based on an industry-used acronym called FERPs. Ever since I heard it, I've remembered FERPs. It's not a word, but it just sounds funny. So FERPs. And it stands for functionality, usability, reliability, performance, supportability. Plus is actually FERPS plus and more. And so a lot of the other big list of words that we see here can fall somewhat in these buckets. And we're going to dive into these and so that we can have a more intuitive understanding of these quality attributes. There's one issue I have with this. So this is my personal take on this. I'm going to make a suggestion of how we remember this in our minds, which is going to deviate from the industry norm. So bear with me. And one of the reasons I feel free to do this is because this was, introduced some decades-ish ago. So I feel like times have changed, and there's one aspect of this I think can be improved. For some reason, when it was either someone at HP or IBM that came up with FERPS plus, security was included in functionality. And I think security, because security is somewhat of an arms race and just ends up, as time goes on, it becomes bigger and bigger of a deal, and our tactics against it have become bigger and bigger of a deal. I think security is worth calling out on its own. So I would suggest replacing, as you think about this in your head, replace the S with security and put maintainability under the plus. That's how I think about it in my head. Not like that's, worth it, but security definitely is worth a special call out. Yeah. I'm pausing in case someone wants to interrupt me. I'm still waiting for that. Okay, before we dive into it, some things to keep in mind. Quality attributes are at odds with each other. This is why saying something like the system has to be perfect is meaningless, because you will have to make trade-off decisions. And if you're not making those decisions, you're not introducing quality to your product. So when you look at what could be a trade-off of performance and going back here, performance and security. If I'm saying the system has to be as secure as possible and has to be as fast as possible, that's impossible, because with security you should encrypt things. That takes time, and to the extent that we do that, are we going to meet our performance requirements? My favorite one we'll dive into in a little bit, but can you think of how performance and reliability would trade off with each other?
I guess it's a moment of deep thought.
Yeah, I'm pausing for myself too, but something to think about, and we will see examples of that. And as you think about it and you realize this is all about making trade-off decisions, that's going to make all the difference. So quality attributes are at odds with each other. Lists are not complete. So FERPS plus, I'm glad it has a plus, because you do have to come back to, we're really trying to solve a user problem and give value to the user. It's not just checking off boxes of the ERPs. I have to understand, is there another quality attribute here? And there's ways of introducing that to your requirements. Because lists are not complete, what is the point of lists then? And the whole point here is we really want to try to disprove our understanding of the problem. Use the list to generate questions of, well, did we think about this? Is their problem still gonna be solved if this happens? So continuously be asking questions of, are we still gonna be able to meet the user's need under this environment? Are we still gonna be able to meet the user's need if they do this thing? And we'll figure out prioritizations to those. And sometimes that's how you can deviate from the list, because the whole point is we're trying to disprove our understanding of the problem. Our requirements are really just a hypothesis of, do we think this system will solve the problem? And if there's any point that we can disprove that, that's a big win. Yeah. Okay, so let's explore some quality attributes. We're going to go down the rabbit hole. And I'm going to, before I need to stop myself, because when I was showing my slides to my wife earlier last week, I realized I don't have time to say everything. So we're about to see a lot of lists. I'm not going to just read out the lists. I'm just going to highlight what I think are the most interesting parts of this. Okay. So we're going to dive into usability. I think in today's world, where we use a lot of really usable software, we don't have to, we may have an intuitive sense of what this is like. Here's a breakdown of some of the goals that the actor, the end user, would be trying to achieve that's related to usability. The main thing I want to highlight here is that each one of these goals are actually something we can measure. So one of the interesting goals here is that users are human. Users will make errors. And for the user to actually have their goal satisfied, we can't just, well, you made an error, user, deal with it. We want to have the error. We want to have the user use the system effectively, even if they make mistakes. So we want to try to minimize user errors and anticipate those. And that's actually something you can measure. And that's actually something you can measure automatically. Like you can detect, hey, our users having to go back and forth between pages a lot on a live production site. And there's really interesting talks given about that. I'm not going to try to dive into it here. But one also interesting part of these are things we can measure is these are also things we can make requirements for. For instance, we can have a requirement for it should take less than 30 minutes for a new user to be able to fill out the form. And if that's like an acceptance, if that's an acceptance for criteria, that's going to help us make decisions as other architectural requirements may start to challenge that. So measuring has two parts. One is we can monitor the actual running application with these metrics of, what's the variety of the user environments. But measurements also means we can formalize and specify these in our requirements as well. And anticipating them as early as possible prevents us from missing them later on. So this is where I'm deviating from the textbook a little bit. I'm adding my own experience and perspective here of what are some tactics, architectural tactics and process tactics for that we can use to address usability problems. From a process perspective, this is proven for me to be completely critical, is having a UX expert that's involved in the team from requirements to code review makes a big deal. From requirements makes sense of UX experts have such a great sense of user machine psychology of what's going to be intuitive and what are the trade-offs you're making on the interface, that having that perspective is so valuable. But also having them involved in code review can pay off a lot of now that they're actually seeing a working prototype of a thing. That's feedback is super valuable, and they might have a different perspective of what needs to be done. So in GitLab, anytime we make a front end change, in addition to code review, we also have a UX review, and oftentimes the requirements change from that. It's just once you see something active and live, that things might change there. If you can, involving actual users, getting their feedback is critical. If your customer is a proxy to the user, do as much work as you can to get involved with the actual user. And UX researchers do that a lot by researching, performing research tasks with a focus group of users. Getting more technical, this last point is all about constraints. You want developers to be not have to think about what the UX needs to be, and to have a framework and library and system for this is how we do a button. This is how we do a form. We need to solve this problem. This is the component we use. And so adding constraints reusable constraints is a big deal. So I linked to just an example UI component framework. At GitLab, we build our own based off of Bootstrap Vue. And I also linked to a design system, which has a whole lot of interest, which is our design system we build at GitLab, which has a whole lot of interesting topics of like, here's how we lay out buttons and stuff. And we try to create components for it so we never have to solve the problem again. Okay. From architecture perspective, we want to identify what are our user environments as early as possible. We definitely want to architect for the most constrained environment first. This means if you're doing front-end development and IE8 is one of the browsers you're going to have to support, you don't want to do that at the end, unfortunately, even though that's the least fun part of what you're going to be doing. You want to try to do that as early as possible, because if this is a big deal that your application supports IE8, and given that that's the environment with the most constraints and issues, we want to solve those problems first and then abstract to the more flexible environments later. And this also applies to, are we doing mobile design? Are we doing full desktop displays? And then lastly, this is my favorite, and I love having these conversations of prioritizing user error prevention, recovery, and reporting, making the product lovable for the user to where I make a mistake, but the product helps me. And one of my, these days, I'm learning and writing a good amount of Rust. I really enjoy Rust. And one of the things I really love about it is when I make a mistake, because I'm learning it, the compiler says, hey, you made a mistake. I think you meant to do this. And the compiler actually is teaching me how to write the language is super helpful. And taking that idea, abstracting it of like, well, the compiler is actually really helpfully reporting my user error. How can I do that in my products of, hey, you did this. Did you mean to do this? And that means that certain things may need to have special information, and that can be an architectural decision. Okay, here's some use cases of diving into usability and different products in the world. I'm going to look at time to make sure I'm not running super late. I'm going to start moving a little bit faster, and we're going to skip some slides. But I do want to highlight this. This is by far my favorite software I've ever used. And if you ever have to flash ISOs to drives, I highly recommend you use this because it just works. And it's really simple to use. I've used this on weird Linux distributions, and it just works out of the box. So this is this product. There's nothing more to this than this screen that I took a screenshot of. But it very simply, you just select the image, select the target, flash, and you're done. And it just works across a number of different environments. One of my personal favorite usability experiences. On the flip side, and this is a tragic case of usability being involved in and software systems with high consequence. The Boeing 737 plane crashes, which resulted in people dying and was a huge tragedy. Some of those incidents, it's a software failure that was identified, but part of it too is also just a usability failure of when the software acted this way, it was expected that pilots had this specific checklist memorized. And that's actually recommended against the FAA to build systems that require that. But being aware of usability and it can have severe consequences is a big deal. All right, I'm going to skip this one. We're going to dive into reliability. Well, before I do that, does anyone have any questions or thoughts about usability?
Hey guys,
Okay.
don't be shy. But yeah.
Yeah, none. It's pretty straightforward for me.
Yeah. No, I'm just wanna. I'm pausing for myself too.
Yeah.
Reliability. This is a big deal, and looking at the right-hand side with uptime, this is a metric we see a lot, and especially in like customer contracts of the system shall be available 99.999% of the time. But these other measurements are things we may not be thinking about a lot, of not needing to be manually reactionary to faults, but is there a way that the system could detect faults itself and could even automatically recover from faults? And so our tactics for addressing this quality attribute fall into buckets of wanting to detect faults, recover from faults, and preventing faults. In detecting faults, one of the most interesting things is just monitoring. And this is an interesting tactic that addresses this use case because it affects all of your code. It's one of the things I would call a cross-cutting concern. You're not going to have the monitoring controller. You're going to need to monitor all your controllers. And with a lot of these quality attributes, you run into tactics of like, okay, well, we need to do this for everything. And monitoring is one of them. And it's something, and that enabling that kind of observability at all the different levels is a big deal, and something that you need to architect for and understand. Recovering from faults, redundancy is the name of the game these days, of having containers and having copies that we can replace with when things go down. And so from deploying multiple copies of the same service there's somewhat of a solved problem. There's one aspect of it that there's one item here that I want to highlight, which can be a challenge, which is rolling back. So let's say we're introducing a new version, and that version is actually, we don't realize is going to break things, and then it starts to break things, and we realize I have to roll back this version of the service to before we made that change. Hopefully we're all using source control, so that's not hard to do. If you're building your system so it's not one monolithic system, and you have different services all dependent and talking to each other, if I have to roll back a specific service because there's a bug or issue with it, well, did I end up breaking an interface that another sys service was dependent on now, such that rolling back has a propagation effect if I have to roll back a whole bunch of things now? And this brings up an interesting challenge, and this is a maintainability challenge of being really, really mindful of when you're breaking interfaces, and the ability to roll back smoothly and not have a propagation effect of needing to roll back comes from, let's be really hesitant to break interfaces. Let's do that incrementally, and let's make changes that are backwards compatible. So that's something to architect for and keep in mind of, this is a goal we want to have for a software project. We want, when we make a change, keep our interfaces so that we can safely roll back without breaking other services that may be dependent on new interfaces. Over here in preventing faults, packaging things in transactions so that if all these operations, if they all have to pass, they all pass, and if only some of them pass, we roll them back and we fail the whole transaction. That is a big deal. It shows up in database transactions, but sometimes you have to build transactional systems when you're not just when you're doing things outside of a database. End-to-end shadow testing, so having a shadow of the actual production environment that looks and is updated and looks like production, but we use it just for running end-to-end tests that are close to what production is going to look like, pays off dividends, because we could do unit testing, we do integration testing, but when you test it as it's actually running in its actual system, that's how you can really raise your confidence level of this is safe to use. And so I added a guide to how we do end-to-end QA testing in GitLab, which is always interesting for me to learn, because we have our whole QA team that writes these tests that look really pretty, and trying to do it in a performing way is interesting. This last point, when I say exceptional unit testing, I don't mean exemplary, like excellent unit testing. I mean, we want to unit test at the unit level, the individual class, the individual code file for exception cases. When it comes to reliability, your system is only as reliable as your weakest unit. And sometimes at these higher levels of testing, you just can't get the value coverage that you can at the unit level. And so we really want to target when I write a unit test and I'm writing certain contexts, if your unit test is missing anything like when the response is completely unexpected, we want to answer those questions at the unit level. And one of the things that inspired me for promoting this is when I listened to a talk by one of the leads at Boston Dynamic, and someone asked them, how are your robots? So Boston Dynamic builds the robots that you can abuse and they still love you. And they asked, how are your robots so effective after, you're pushing them around and in different terrains? How are they so reliable and they're still, able to do things? And he said, you have to build reliability at the lowest level of your system. And for a lot of us, that's at this unit testing level. Okay. For the sake of time, I'm going to skip through this. With Netflix's highly reliable system, one of the most interesting things they've done is implement a service that actually tears things down in production. Rather than assuming everything's going to go fine, they actually force things to not go fine so that they're forced to solve those problems. Yes, I'm going to skip through that. And I'm going to speed through performance. Okay. But I do want to highlight security because security is interesting. One of the, this is not a really interesting slide, but mainly the goal here is not assuming all of your users are going to have the best intention at heart. So everything can be active. The whole interesting point here is that your user has a goal that you're not trying to satisfy. And you want to be able to identify those. So these fall into the categories of resisting attacks by users and reacting and recovering from attacks. To resist the attacks, critical step is identifying and authenticating all of the actors. Authenticating means that when an actor says, I'm this, you know for sure it's that. If you can't identify actors, you won't be able to revoke their access if they end up being a bad actor. But these last 3 points are pretty critical for a software application to stay safe. Any running process should have limited access only to the things that it needs. Make sure that your processes, like your web server, isn't running under some root privileges, so that if the web server is compromised, it's able to do a lot more damage than just what it was allowed to do. If your web server doesn't need to reach out to the network, don't allow it to reach out to the network. So anticipating those and minimizing the possible damage goes a long way. This point, keep dependencies updated, because software these days doesn't stand on its own, and it's built on top of a whole bunch of other software. You want to stay relatively up to date, because whenever the version you're currently on has it's discovered that there's some sort of security vulnerability, you want to be able to easily update. So even if there's no security vulnerability with your current version, there might be one day. And if I'm now 2 or 3 major versions behind, it's going to be a nightmare for me I'm going to have to refactor potentially the whole project. And so staying up to date is a big deal. I would suggest not being at the bleeding edge, because that means you're probably going to inherit, whatever new security vulnerabilities people are creating before they discover them. And then lastly, highly suggest us as software engineers really like solving hard problems. But security is one of the problems you want to not have to solve and think about, because it's a really hard problem. And so leaning into frameworks goes a really long way. I'm thinking from a front-end development perspective. If I'm building an HTML out of a string, there's so much that could go wrong there, as opposed to if I'm using a component framework like React or Vue, even if nothing is dynamic. leaning into the framework. A lot of frameworks have solved this problem too. I got to talk about this. This is my favorite security example. I'm not sure if anyone remembers this controversial Twitter account, but Microsoft created this AI chatbot that the more you talked, the smarter Tay got. After 24 hours of activity, Tay quickly turned into a Nazi and an incredibly the worst version of anybody on Twitter possible. And what's interesting here is it's not that anyone had unauthorized access to Tay, but because Tay learned from anybody talking to it, you had an open field out on the internet. It's going to attract and gather whatever the internet throws at it. And there was no protection against garbage being thrown at it. And the results, although from one eye could be humorous, but also wildly offensive and a PR nightmare for Microsoft. Okay, this is one of my favorite trade-off examples. How could usability trade off with security? I'm going to pause here for us to reflect on that. And as we're reflecting, imagine we all know the person that can't remember passwords and has to write them down. Usability and security are 100% at odds with each other, but they need each other. If you are implementing security practices and it's not usable, users will circumvent the security practice and completely get rid of any kind of security you tried to have by creating a text file of their passwords or whatever like that. So usability and security absolutely need each other, but they're at odds with each other. And this is where having a UX expert involved at what can we do to make this as easy as possible for users, but keeps them secure, is a really hard problem to solve and one not to take lightly. Okay, I am going to dive into, I'm not going to talk about goals and measures of maintainability. Oh, yes, someone interrupted. Clyde, you rock. How about using password keepers? Does it trade the usability with security? And yeah, I think I really like 1Password, and I think it's a big deal because I came up with a system for me to try to come up with passwords and remember them, but it wasn't perfect, and it definitely failed whenever I did need to share the password. So password keepers really helped at being able to securely share them. Two-factor authentication goes a long way. But with web services, I think there's a lot of patterns we can follow. There's a lot of problems that are already solved here. There's some instances where, and imagine if you're doing something with like cryptocurrencies, where security isn't just a matter of a password and you have to deal with certificates and other things. This problem of usability and security is still definitely there. It's funny how in the wild, some people have just completely failed the usability security trade-off, like not allowing people to paste in passwords and thinking that that helps, but it actually completely doesn't, because then you can't use a password manager. But yeah, that's a good question. Thanks for interrupting, asking that, Clyde. Appreciate it. Maintainability is such a big deal because requirements will change. You want to make sure that you can, your developers are productive, and just saying the system shall be maintainable is not good enough. Keeping an eye on these metrics of how much time are we spending on doing a thing? How many regressions are we introducing per change? How much time does it take for a new contributor to be productive is a big deal. So there's so much written about increasing cohesion and reducing coupling, which is basically what maintainability comes down to, keeping modules, responsibilities isolated and keeping modules from being tightly coupled to each other. I'm just going to fly through the most interesting bits. Testability is a great metric for maintainability. If something is hard to test, it is hard to maintain. And so test-driven development is all about, we're going to write the test first so that it must be easy to test, implying that it is maintainable, it is easy to change. So prioritizing testability as a means to get maintainability is a great tactic. And this is something I've learned over the years, is that the perspective of a newcomer can be worth 10x than that of a veteran. And I use 10x intentionally. We've heard about project managers looking for the 10x engineer that can do 10 times the work, 10 times better than anyone else at 10 times the speed. The reality is that's not realistic. And the bigger reality is you have way more newcomers than you do have those people. And if a veteran should really value the perspective of newcomers, because we want newcomers to the project to be wildly productive. And so building systems that are really complex, that are siloed, that only a certain individual knows how to actually change and deal with, end up falling apart because not everyone can pick it up. But if you build systems that almost anybody can pick up and follow guidelines for being productive, and that goes a really long way. So anytime we're talking about maintainability, I'm nervous about the things I produce, and I wildly value the perspectives of complete newcomers. So collaboration is key here, and especially collaboration amongst novices and experts. I love that. Clyde, you asked another question, and I skipped it. Blogs on TDD's design is dead. Oh man, I'm going to get back to that one. I'm going to put a pin on that, and that's a really good question. And I have a small story about that. Okay, I'm going to just fly through functional teams, but quality attributes doesn't just apply to your product you're building. It applies to your team. And Conway's law dictates that teams are destined to build products that reflect them. So you really want to ask, is my team resilient? Is my team, how many people need to get hit by a bus before our team falls apart? And if it's all one person is carrying the weight of the whole team, that's a really good sign that my team is not as resilient as it should be. Are people having fun? Is your team having good retention? And those are things to be cognizant of. And I want to highlight just briefly one of the best examples of a working culture that I've had the privilege to be a part of and also just learn about. Being at GitLab, I've never seen a company do this, where we have a handbook that we take so seriously and we quote it to each other, and it's the foundation for the decisions we make. And some of our values, our values are collaboration, results, efficiency, diversity, iteration, transparency. I want to dive briefly into those values, and then we will call it a day. But highlighting collaboration in your team from a culture perspective, this is in our mission statement at GitLab, but everyone can contribute, to where if you're the lowest person on the organizational chart talking to the highest person on the organizational chart, that perspective is so valuable, and ideas stand on their own, not the titles behind them. Everyone has short toes, meaning that if I build something and someone else starts building on top of it, I'm not going to feel like, hey, what are you doing to my code? We're all contributing to the team's collection of things that they own. And then continuously practicing having no ego and eliminating internal competition by working on providing value just to the end user. And that's, everything is going to be user-centric, not professional development-centric. And some of the ways we meet that is because we're a fully remote distributed team, just getting to know each other and collaborating with each other goes a long way. In practice, I love pair programming. And so even though GitLab is completely distributed and remote organization, we still have ways that we pair program with each other. And those synchronous collaboration sessions are really magical. And the feedback that we get there is fantastic. And but because we are fully remote, it's not realistic for us to pair program all the time. So we do take code review really seriously, and that's not an approval process, it's a collaboration process where we don't want no code gets merged in without going through multiple people's heads. And once we know it's through multiple people's heads, we know it's probably maintainable and good. Yeah, and I think I'm gonna end it there because I went a little long. So I can get back to Clyde's question. I can open up for other questions, like promote this religious adherence to everything shall be test-driven development. I have a friend that I work with who was in a who worked at Pivotal, which is famous and infamous for strict adherence to extreme programming, which promotes strict adherence to test-driven development. And there's some huge challenges with that. And we both agree that him having done it professionally for a long time and me having done it just individually, not doing it in a team that was trying to promote that, it's a really good practice to adopt at some point in your career because it builds just a certain insight of what's going to be easy to test and what's not. But I think these days, that final point of if something is hard to test, it's hard to maintain. That's the biggest lesson for me that test-driven development teaches. If I'm having a hard time testing something, I should go back and change it. And sometimes that means let me write the test I wish I was writing, and then let me go back and change it so that it can fit that. But I don't really promote a strict adherence to test-driven development. I do think it's helpful in some cases, but yeah, I don't think strict adherence is necessary.
Thanks, Paul. I have a few questions from the guys. So Paul, this is more of a personal question, I guess. Working in GitLab and contributing to the open source, how many hours do you dedicate in front of a computer? Can you run us through a typical day for you? I mean, how do you make that all work?
That's a freaking good question. GitLab is a great organization that it realizes different people work differently. We have to do that because we hire people from all over the world. So we're really encouraged to be managers of one, meaning that I'm not required to be in front of my computer for 8 hours a day because I will not be very productive. I'm the kind of person that has to go for a run to, like, that's when I get interesting ideas. When I'm not in front of the computer and I'm walking around or I'm doing something else, that's when my subconscious is working on problems that I'm then excited to bring back to the computer. Related to that, because we are all remote, all of our communication happens through the keyboard. So I actually spend probably 50% of my time talking about software than actually writing it, talking about what we should do than actually doing it, which may or may not be a good thing. And so I do spend a good amount of time at the computer just doing asynchronous communication, code reviews, that kind of thing. Yeah, that's an interesting question.
And I have another one from Michael Brewer. What are your thoughts on Git-Flow versus trunk-based workflows? What is the current best practice?
Can you say that again? Git-Flow versus?
Trunk-based workflows.
I'm not familiar with trunk-based workflow. I'm really familiar with Git. And at GitLab, we do something really interesting where we require, because I said our handbook was public, our handbook is public, we actually require every newcomer to make an addition to our handbook. This is something that it's a live document everyone can make changes to. And it's actually a Git repository that, whether you're in legal, sales, or engineering, you're going to learn how to make a contribution to a Git repository. So I do think Git, even though it gets criticized for being a little complex, and it kind of is, there's ways, and hopefully with GitLab, we've tried to make it easy. I hope I answered the question. I hope I didn't just try to sell GitLab to you all.
No. I guess I just also have one more question. Does non-functional FERPs reduce technical debt?
Yes, because maintainability is a non-functional requirement. Maintainability is all about reducing technical debt. And that's a functional requirement that needs to be highly prioritized because we work, whether we realize it or not, requirements will change. The environments will change. We need to change the thing. And maintainability is all about addressing that problem. And that's a non-functional requirement. So the answer is yes.
And one last from us. Has it ever gotten you into trouble when you try to prioritize what is the most important for the user versus what your client or your boss asks of you? And what do you do and what can
I
you
am
recommend?
I'm so freaking excited you asked this question. I'm going to try to go back and hopefully not give anybody a seizure while going back. Going to usability. Yes. So one of my most frustrating, here we go. One of adapt to user environment, and that you can measure the variety of user environments. One of my most frustrating conversations professionally has been people and managers and product managers that are trying to steer the ship in a certain direction, adhering so much to what the data says that they miss what the actual user problem is. And we have some features that are so not user friendly in certain environments that it's a problem. It'd be nice if they were, but these have been deprioritized. There's some conversations where these have been deprioritized because when you look at the data, we don't see any users on those environments. So why would we prioritize doing it? Well, we don't have any users on those environments because it doesn't work on those environments. And so those conversations definitely do happen. And it's thankfully having a culture where anybody can challenge, and bring up these things. How we thought about this goes a long way. So the way your organization works, and that's why I included this in the last part of the presentation. There's more I could have talked about there. But the way the organization works is critical to meeting these because we want to get everybody's input and value it as it stands on its own, not feel like a product manager is the only one that makes decisions here, even though they are definitely the directly responsible individual.
I hope you all had a nice time. Thank you so much, Paul, for being so generous. Thank you so much for indulging Cloud and our team.
I'm going to publicly post my slides, and then I will share it all with you all to distribute. But on those slides is also how to reach me, and if you ever want to reach out and ask questions and talk, always game for that. I'm a bit of an extrovert, and so working remotely, I cling on to these kind of meetings and I apologize for going long. I do deeply apologize for that. I'm sorry about that.
Yeah,
No
and
worries.
we can
Actually,
also,
we're lucky. Yeah, go ahead.
yeah, sorry, Mom Shi. Yeah, we can also subscribe to your YouTube channel, Paul.
You will
There you
not
go.
be disappointed if your expectations are at an appropriate level.
Thank you again, guys. Have a nice evening in Manila. Have a nice morning to you, Paul. And I guess you're also working today, right? So yeah, thank you so much, everyone.